How are the range and domain of the inverse relation related to the range and domain of the original relation? Let's look at an example and see if we can notice what's going on. Let R be the relation consisting of the three pairs 1, 7, -1, 5, and -3, 3. Then R inverse consists of the three pairs 7, 1, 5, -1, and 3, -3. Again, just swapping the entries of the pairs. So let's see. The domain of R is just the things that appear as the first entry in an element of R. 1, -1, -3. And then the range of R is just the things that appear in a second entry in R. 7, 5, 3. What's the domain of R inverse? Well, it's all the things that appear in a first entry of R inverse. So 7, 5, and 3. What's the range of R inverse? Well, it's all the things that appear in a second entry in R inverse. It's 1, -1, -3. Do you notice a certain similarity here? These two are the same set. These two are the same set. Is that a coincidence? I don't think that's a coincidence. Why not? Well, every first entry in an element of R, when we swap the coordinates, of course it'll turn up as a second entry in an element of R inverse. Every second entry in an element of R, of course it'll show up as the first entry in an element of R inverse. This will always be true. It will always be the case that the domain of R is the same as the range of R inverse. The range of R is the domain of R inverse. This will come in handy later because we'll find it easier in some cases to find the domain of a relation than we do to find its range. At the moment, this gives us an easy way to fill in missing sets, right? Suppose we have some relation S, and we know its domain is the interval from 1 to infinity, including 1, and its range is the set of three numbers 1, 2, 3. Suppose we wanted to find the domain of S inverse and the range of S inverse. Using this fact, pause the video and answer this now. All right, we know the domain of S inverse is the same as the range of S. So this must be the set 1, 2, 3. We know the range of S inverse is the domain of S. So this must be the set 1, infinity. We don't need to know anything more about the structure of S to be able to say this.